We are starting with the review of mean and standard deviation, the basics of mean standard deviation in relation with raw data, frequency distribution, and then advanced questions in which a person enters or leaves the group, advanced questions in which there is combination of two sets of data. What is mean? Mean is a measure of central tendency, a measure of location. It takes all the values into consideration. For raw data, mean is sigma x over n, where sigma x is sum of x. N is the number of sample. For frequency distribution, the mean is x bar sigma fx over sigma f. What does sigma means? Sigma means addition. What does fx means? Product of f with its corresponding x. What is standard deviation? It's a measure of dispersion. It's a measure of variability. How far spread out is the data? These were the formulas that are given in the formula booklet, MF19. One formula for mean for raw data, one formula for mean for frequency distribution, two formulas for standard deviation for raw data, two formulas for standard deviation for frequency distribution. When we talk about raw data, this is the first example that we should focus on. 1, 2, 3, 4, 5 pieces of data observations are given. This could be the marks, this could be the height of a plant, this could be weight of apples. Sigma x, sum of x, simply add them up. Sigma x square, square each value, order matters. Square each individual value, then add it up. That's how it's to be done. Sigma x over n, that gives us the mean. Sigma x square over n minus x bar square, the whole thing under root, that is standard deviation. We know that variance is square of standard deviation, or standard deviation is square root of variance. Then there is another formula which we don't need to use as such, except we should know how the formula looks like. The formula looks like this. We talked about the numerator in the previous class. I won't focus much onto it. Frequency distribution, sigma fx over sigma f. Standard deviation, sigma fx square over sigma f. What is sigma fx square? Sum of product of f and x square. Keep in mind that sigma fx square is not sigma fx the whole thing square. Sigma x square is not sigma x the whole thing square. So there is no such thing as this. Okay? Let me remove the misconception. Sigma x square is not sigma x the whole thing square. Sigma fx square is not sigma fx the whole thing square. There is no such thing. Sigma x square, sum of squares of x. And how would you calculate this? That is illustrated in the next example. Ungrouped frequency distribution, single value of frequency corresponding to single value of x. You have different values of x, you have frequencies, and then you have 3 columns to make. The first 2 columns are already given. It was given in a horizontal table. I changed it into a vertical table. You have to calculate x square, fx, fx square. F into x is fx. F into x square is fx square. You need sigma f of this. You need sigma fx of this. You need sigma fx square of this. This one value, I changed it because there was an error. So it might change this value of 101. Understanding the concept is necessary. Using a calculator, you can use it. What about class interval and class boundary? Just focus on the mid value. Mid value can be obtained from the average of upper class interval and lower class interval. Mid value can also be obtained from the average of upper class boundary and lower class boundary. In this particular question, 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 49, we obtain the mid value by taking the average of the two intervals. And the rest of the story is the same as before. A detailed version is given over here. It does not make a difference whether the class widths are equal or not, because we are not drawing a histogram at this moment of time. We are simply using the mid value for calculation of mean and standard deviation. Also keep in mind that standard deviation is dependent on the mean. So even if the examiner only asks for the standard deviation, you have to calculate the mean anyway. When we were doing some past paper questions, the basic type, the first question was straightforward. Rachel measured the length in millimeters of some of the leaves on a tree. Her results are recorded below. Find the mean and standard deviation of the lengths of this leaf. So in this question, what's happening is that there were 10 pieces of information. You add up all these, that is sigma x. You square each one of them and then add it up, that is sigma x squared. Apply the formula and then you get the answer. If they ask us for the variance, you remove the square root sign. It's a good habit of writing variance on the left. Variance can be written as SD square. If they ask for the variance, your working stops there. If they ask for standard deviation, take the square root of variance. Do take care of the accuracy. Done? Let's move on. Another question, something like this. A computer can generate random numbers which are either zeros or two. On a particular occasion, it generates a set of numbers which consist of 23 zeros and 17 twos. Find the mean and variance of these set of numbers. Two values of x, two corresponding frequency. Rest is simple. The 5-column method, x square, fx, fx square. This question could also have been done using the concept of DRV, discrete random variable. Probability of getting a 0, 23 over 40. Probability of getting a 2, 17 over 40. Then there are 4 formulas that we are focusing on. Let me rewrite them once and for all. We have to write them over and over again. Standard deviation, that is sigma x square over n minus x bar square. Standard deviation, that is sigma x minus x bar square over n. You don't have to remember this. It's given in the booklet. It's totally something else that when you use something excessively, it becomes part of your memory. When these two formulas, they are related with raw data. And another two formulas, they are related with frequency distribution. SD, that is sigma fx square over sigma f minus x bar square. And SD, don't forget the square root. SD, that is, I can remove the square root, that would look neater. And this is sigma fx minus x bar square over sigma f and its variance. Both the formulas I've written for variance. These two are for frequency distribution, whether it's ungrouped or grouped. Now, if I look at these summarized data questions, let's look at the first question. For a set of 10 numbers, so you would write n is equals to 10. You would write sigma x is 290. You would write x square, sigma of x square is 8469. What is it asking for? Mean and variance. So x bar, I'll simply write down these steps. Sigma x over n, which is 290 over 10. Variance SD square. Therefore, sigma x square over n minus x bar square. This is 8469 over 10 minus 29 square. and that is your answer because they're asking for variance. If they would have asked for standard deviation, it would be square root of this answer. Straightforward. Next question. For a set of 9 numbers, this thing is 234. So n is 9. Sigma x minus x bar square is 234. Which formula is useful? This formula is useful, the second one. So therefore, x bar, not x bar, variance, that is sigma x minus x bar square over n, which is 234 over 9. Therefore, if they ask for standard deviation, that is 234 over 9. Next question. For a set of 9 numbers, n is 9, sigma x minus x bar square is 60, and sigma x square is 285. Find the mean of these numbers. Now, in this particular question, you have to use both the formulas. The variance is sigma x square over n minus x bar square. Variance is sigma x minus x bar square over n. So if I equate this with this, so therefore what will happen? What will happen is this: sigma x square over n minus x bar square is sigma x minus x bar square over n. What is n? 9. So therefore this is sigma x square is 285 over 9 minus x bar square. It is equal to 60 over 9. And you can conveniently make x square the subject, and then you can make x bar the subject. X bar square the subject, and then you can take the square root, and you will get the value of x bar. What about this question? For a particular set of observations, sigma f is 20, sigma fx square is this, sigma fx is this. Find the value of mean and standard deviation. So now this time, which formula would we be using? These two. This one or this one? I think the first one we are using right now. X bar, sigma fx over sigma f. Sigma fx is 563, sigma f is 20. Variance is sigma fx square over sigma f minus x bar square. Sigma fx square is 16143 divided by sigma f is 20. X bar is 563 over 20 square. This is variance. In the end, make SD the subject. Last question of this type. For a given frequency distribution, sigma f x minus x bar square is this much, and sigma fx square is this much. Again, it's a combination of both formulas. Sigma fx square over sigma f minus x bar square. Variance, sigma fx minus x bar square over sigma f. Use this along with this. So therefore, sigma fx square over sigma f minus x bar square. This is sigma fx minus x bar square over sigma f. They're asking for the mean. This is 1025. This is 30. This is mean square. This is 182.3. This is 30. And then you make x bar square the subject. And then you make x bar the subject. So now these 5 simple questions were just playing around with the formula. Could be using the formula, only one formula at a time, or could be using 2 formulas at once. Now let's look at the past paper questions. Before we proceed, we are just reviewing what we have done in the first class. Okay? So x bar is sigma x over n. If x bar is given, n is given, how can you calculate sigma x? Sigma x, summation of x, is a product of average multiplied by number of pieces of data, which we also call as the number of observations. Let's look at the first question. The ages of 18 people attending an evening class is summarized. Sigma x is given, sigma x square is given, calculate the mean and standard deviation. That was straightforward. Second part, one person leaves the group and the mean age of the remaining 17 people is exactly 41 years. That means if I want to calculate sum of ages of 17 people, That is 41 multiplied by 17. That comes out to be 697. Sum of ages of 18 people was 745. Sum of ages of 17 people is 697. What's the difference? Difference is 48. That means the person who left the group, his age was 48 years. Now, we want to calculate the standard deviation for the remaining 17 people. Now, here is the main issue. Sigma x, summation of x. Sigma x squared, summation of x squared. That means if one person left the group, if I have to exclude its data, so his age was 48 years. Individual ages were squared and then added up. That means if one person is leaving the group, his age should be squared and then subtracted from 33951. Is this thing clear? Listen to it again. How do you think they obtained 33951? Somebody must be of age 37 years, someone 42, someone 45. So 37 square plus 42 square plus 45 square plus 48 square plus 49 square plus 50 square, whatever the ages were for 18 people, they all added up and gave you 33951. Now, one person is leaving the group for whatever his personal reasons or whatever reason that is. You want a new x square. Now, there are two options. If you have the original 17 numbers, you could have squared each one and found a new one. Or, what's the shortcut? Subtract that 48 square, and then you get a new sigma x squared. That is 31647. Based upon that, based upon the new mean of 41, you calculate standard deviation for the remaining 17 people. Okay, let's move on. Combination of sets of data. That was the next thing. A lot of questions we did on this. When we combine sets of data, the first example is straightforward. The mean of a sample of 25 observations is 6.4. The mean of a second sample of 30 observations is 7.2. Calculate the mean of all 55 observations. X bar, sigma x over n. Sigma x is number of observations multiplied by average. For 25, the sum is 160. 25 into 6.4 is 160. For 30, the sum of y is 30 into 7.2. 160 plus 216, that is the sum of all the 55 observations. And then we divide by 55. What do we get? We get the answer as 6.84. That is the overall average. Everyone clear on this? Let's move on. Combination of sets of data. We are focused on 3 questions. This was the first one. That was not a past paper question. And then there were 2 past paper questions, the garage one and the man and the woman one. Let's focus on each one of them. And then we will start the topic for today's class, which is assume mean and coding. Now, in the first one, for a set of 20 numbers, sigma x is 300, sigma x square is this much. For a second set of 30 numbers, sigma x is this much, sigma x square is this much. Find the mean and standard deviation of the combined set of data. That means what I can write is that for combination of sets of data, I need 2 things. I need number in the group that is equal to number in set A plus number in set B. I need sigma x for the group. I need sigma x for A plus sigma x for B. I need sigma x square for the group. I need sigma x square for A and sigma x square for B. If I have all these available, I can calculate, I can say that x bar for the group, that will be sigma x for the group divided by number of the group, and variance for the group is sigma x square for the group divided by number in the group minus x bar of the group squared. Agreed? So this is the strategy behind it. Understand the strategy, what you're out to get. If everything is available, it's perfectly fine. If something is not available, maybe you have to do 1 or 2 more steps to get those things available and then work it out. Now, let's look at the question again. What do you have? You have number sigma x square for each set of data. That means it's a perfect, simple, easy question. You add both the sigmas, which I have added over here. This is 300, this is 480 divided by the total. That gives you 15.6 exact. Similarly, what you do is that you add sigma x square by adding 5500 and 9600. So this is 5500 plus 9600. You already have the x bar obtained from before. Number of people in the group is there. Therefore, you get the variance, and then you calculate the standard deviation, and of course, take care of the accuracy. Straightforward. This is the strategy that you have to follow. Now, in the next question, what we are doing is that, for example, in some question, they might have given us the mean. They might have given us the number, and they are asking for sigma x. So you would say sigma x is n multiplied by x bar. Maybe in some question, they have given us standard deviation, and they have given us number, and they have given us x bar, and they are asking for sigma x square. Can you find it? Yes, you can. Standard deviation square is sigma x square over n minus x bar square. Make sigma x square the subject if you have studied O-level math properly. SD square, x bar square, bracket closed, multiplied by n, that is sigma x square. Now the strategy is you have to do all this, but if sigma x is missing, what should be done? If sigma x square is missing, what should be done? This should be done. Sigma x is number of observation multiplied by mean, and sigma x square is variance plus square of mean, bracket closed, multiplied by n. Let's look at this question, the garage question. The red garage, number is given, x bar is given, SD is given. So you first find sigma x for red garage, which is 32.4. You find sigma x square. Either you remember the formula or you manipulate the formula at the moment, at the instant. So sigma x square is this. Once you have obtained sigma x square for red, once you have obtained sigma x for red, the question is as simple as the previous question. For the mean, add both the sigma x divided by the total number. First, add both the sigma x square and then carry out the standard deviation for the group formula. Take care of the accuracy. That will be re-emphasized over and over again. Because when you understand a concept in its totality, and then it's very stupid to miss out marks just on some O-level math significant figures. So take care of it. Now, one last question before we start the second video. This question is about 10 married couples, 10 men, 10 women, and 3 single men. The data is given as it is. For men, you have the mean, you have the number, you have the mean, you have standard deviation. For the woman, you have the mean, you have the x bar and the number. So basically, what you have to do is that you have to find sigma x for men, sigma x for women. You have to find sigma x square for men and sigma x square for women. And then it's back to the basics. Sigma x first, let's look at the basic over here. You add both the sigmas and you get 1013, sigma x that is. You find average for the whole group. You find sigma x square for men, you find sigma x square for women, you add it up, you get sigma x square for the group. And then what do? You calculate the standard deviation based upon the overall average, which was 44.08, unrounded value. So far, what we have done is that we have studied questions related to basics and so on. And now what I'm going to start in the next video is that I'm going to start with the concept of coding.